Okay, law of sines was so much fun, we decided we'll go ahead and do a law of cosines. And remember, we're not in the land of right triangles anymore, so we used to have this thing called Pythagorean theorem, and you might remember it. RR, A, B, C was always the hypotenuse in our nomenclature, and we would say a squared plus b squared is equal to c squared. Okay, that was before. Okay, so this was not what we're doing now. What we're doing now is we don't have a right triangle anymore. So there's absolutely nothing special about where C is. C is just one side of the triangle. It doesn't even have to be the longest side. You know, it can be any of the sides. So there's nothing special about who's A, who's B, and which side you decide to call C. Nothing special at all. Okay? So with this nomenclature, you can do it in any order, but I'll choose it so it looks the most like what you're used to as Pythag. So the law of cosine states c squared, okay, length of some side squared, is a squared plus b squared. Look familiar? But now, because it's not a right triangle anymore, we have to add this little piece, 2ab cosine of that opposite angle c. Okay? So this is your law of cosines. Okay? So I can find that side, given two sides and the angle between them, okay? Because if you remember what this looked like, this is angle A, this was angle B, and this is angle C. So you have A and B. Say you had these two sides, then you have to know the included angle. So law of cosine works really well for this side, angle, side. Okay? I knew the two sides, and I knew the included angle. Now, if you wanted to, let me go to the next page, first of all. If you wanted to rearrange all the letters, you could. I don't ask you to remember this, but if I took that equation and I solved it for the cosine of C, I'd get this, okay? And I would be able to find the angle given three sides. This, of course, is side, side, side. Okay, so I just wanted to show you that. But what I really want you to remember is Pythag on steroids, we call this. Okay? So c squared, you're going to remember, a squared plus b squared, start like you always do, and then subtract this little piece here. And I want to do one little demonstration. I say this works for any triangle, doesn't have to be a right triangle, but what if it were a right triangle? So what if C, indeed, was a 90-degree angle? Okay? This would be side C, the hypotenuse in this case. This would be A and B. What is the cosine of 90 degrees? Well, guess what? Cosine of 90 degrees is 0. So when you subtract 0, what's left is just Pythagorean theorem. Okay? So this is just this little extra add-on in case it's not a right triangle. Okay, let's try this problem that's a side, side, side. They've given me three sides. And the question would be, which angle would be most appropriate to start with? And I'm going to tell you a big hint. You want to find the largest angle first. Okay? That way you're going to avoid these ambiguous cases afterwards. Okay? So find your largest angle and know that everything else has to be smaller than that one. Okay? So find the largest angle. Remember, that's going to be opposite the biggest side. So, what are we going to use? Okay, so that means I'm going to be looking for angle B, because angle B is opposite side little b, and that's the largest side, so big B will be, angle B will be the largest angle. So, we had been writing our c squared, a squared plus b squared minus 2ab cosine theta, cosine c, sorry, as our law of cosines. But you know, if you're looking for the angle B, okay, let me change my color here. Then this is going to be little b here, okay? And then these are going to be the other two letters. So I haven't used a and c yet. So I've got a squared plus c squared minus 2ac cosine b. So now I've set it up for the right letters, right? Okay, so let's go ahead and put some numbers in and square everything. I'll be right back. Let me pause it. Okay, so at this point I've put my values in for a, b, and c. I've squared the numbers. Okay, so that just didn't take up too much time for you. And now I got to solve this for this cosine b. So the first thing I think I'll do is go ahead and add these together. Oh, what is that? 260 minus 224 cosine b. I'm going to need to do a little more work here. I need to subtract 260 from both sides. I'm going to get 101 is equal to negative 224 cosine b. Ooh, the plot thickens. Okay, so I'm going to divide both sides by negative 224. Let me do this, 101 divide by 224. I get negative 0.45 is equal to a cosine of b. Okay, that's really interesting. For the cosine to be negative, you know I have to be in the second or third quadrant. Well, I'm obviously not going to be in the third quadrant. I'm going to be in the second quadrant. So I'm going to have an obtuse triangle here. Wow, that's why we started opposite the largest angle, because here's our obtuse right here. So let's find b by using inverse cosine of negative, don't lose the negative, 0.45. Let me throw that on. And I get b is going to be 116.8 degrees. So there's that obtuse angle. Okay, now I've got to find the other angles. Remember, I already started with 3 sides. I found one angle. I still need 2, so I can't yet use, the sum of the angles of a triangle is 180 degrees yet. I need one more trick. I could use the law of cosines again. I choose not to. It's always, I think, easier, a little more straightforward at this point to go to a law of sines, okay? So I'm going to use the law of sines. I know what A, B, and C were. And I'm going to go ahead and find big A, angle A. So if I want to find sine A over 8, and I'm going to use B, right? Sine B over the length of B. And that will allow me to find sine A. All right, now I wrote sine A is 0.3758. I do not need to see that step from you guys, okay? This step right here, I don't need to see that. I'm only including it for your benefit because you can kind of check and see where maybe you made a mistake or how things are going. The point is, when you take that inverse sine of 0.3758, you're going to get 22.07 degrees. Don't ever forget your degree mark. And I'm not even going to bother with the possible second solution, right, for that ambiguous case, because I already have one obtuse angle and I can't have more than one obtuse angle. So I know this is the angle A, and then it's a really quick matter of subtracting to get the last angle left, okay? And so that'll be the last angle, I think it was C. And I get 41.13 degrees. So now I have all 3 sides, all 3 angles of my triangle. Okay, just like we had a way of finding the area of any random triangle, we're going to do another way, this time when the only thing you know about the triangle is the 3 sides. Okay, so from side, 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 can you calculate the area of that triangle? So I have this formula from Heron's area, and it's a square root, and you see the 3 sides, A, B, and C, okay? But you also see this funny little s, okay? And s has a definition, it's the same in all the places. S is going to be when you add the sides together and you divide by 2. So it's not quite an average, right? That would be divided by 3, but it's just this funny definition. So it's a funny formula. I'll give it to you. You don't need to memorize it. I'll ask you to be able to use a random formula like this one to find the area of a triangle when you've been given 3 sides. So just to review, we've got lots of different formulas for area. Of course, we've got the half base times height, so if you know those, use this formula. The last one we learned was 1/2 b, and in essence we found the height with c sine a, or some other such combination, and then we have our new one. So in almost any situation, we can find the area of the triangle. Okay, I want to do a problem for you that you might see in the back of the book, and I've got a parallelogram, okay? And I want to point out that little c, this length, is for the entire diagonal, okay? So that whole thing is c, and the other diagonal, the whole length, is d. So remember what you know about parallelograms, okay? And see if you can solve a problem if I give you a side A is 5, and a side B is 8, and I can tell you the angle theta is 45 degrees. Now theta is the entire angle of the parallelogram, okay? So pretend that line for the C diagonal wasn't there, and you're measuring theta, okay? Don't forget what you know about parallelograms. Why don't you give this one a try, and I'll show you how it's done if you have trouble. Go ahead and pause it. Okay, so far let me check in. So far I found the length of that diagonal C is 12.065, okay? And I got that because if I'm looking at the C diagonal, I'm looking at this triangle, which has sides 5 on the left, 8 on the top, because remember, opposite sides are congruent in a parallelogram. I could also find the angle phi, which is really going to be my angle C, because I know that subsequent angles are supplementary. I have to make 180 degrees when they're next door to each other. So if I took 180 minus the theta angle here, I've got 135. So that's this angle for C. And now I'm going to use the law of cosines because I have two sides and the included angle. So that makes it a side angle side, which makes it a law of cosines. Okay? If you didn't think about that and you tried to use a law of sines, you'd find out there's no combination that has enough information to solve it. So you kind of would fail law of sines, and you'd be back at law of cosines eventually. But I recognized it was side angle side, so I'm going to have to use law of cosines. So I set it up. It was nice, the c squared. Put all my values in, figured everything out, and got c was that. To find the other values, like, I guess I have to find d still. Is that the only thing left to find? D, I'll just repeat the process on the other side. Okay? Okay, here's the information that I already knew about the triangle, so now I'm going to, maybe I'll find b. Let's find b next, the angle of b. So I'll start with sine b over little b. It's got to equal to the sine of c, which was 41.1, over little c, 14. And now I have to solve this one. So let me get my calculator out again.